Hello, everyone. My name is Brent Lunsford. I'm representing the IEEE Sensors Council and the IEEE Standards Association. I'm the managing director of MEMStronics, and I've been working in the field of MEMS and sensors and mixed signal microelectronics since I started my career in 1995. Today, it's my pleasure to welcome you to the IEEE webinar, Are Sensors the Weakest Link to Cyber Attacks? Now, in 1997, the term Internet of Things was introduced. Today, the Internet of Things describes technologies with sensors combined with microcontrollers that give products intelligence with the ability to sense and therefore creating intelligent or smart products that connect over wireless networks. Everyone attending this webinar benefits from IoT sensors. Ensuring interoperability and cybersecurity are two of the most pressing issues on the path of mass-scale deployment and utilizing the full potential of the Internet of Things. The concept of the Internet of Things is not totally new. Automation sensors have been around for many decades. Today, the difference is IoT sensors are all communicating over the same wireless networks. And today we have two distinguished speakers who will present the topic of cybersecurity as it relates to IoT sensors. Need to give thanks to our technical sponsors for this webinar. That includes the IEEE Sensors Council, the IEEE Industrial Electronics Society, the Instrumentation and Measurement Society, and Foundational Technologies. 3 housekeeping tips here. Upon entering this webinar, all attendee lines are automatically muted. Today's presentation is a one-way broadcast. If you're experiencing any technical issues, use the chat feature and message the host for troubleshooting. To ask questions throughout the webinar, use the Q&A feature. And I do want to note this is a 75-minute webinar, including the Q&A. So please stick with us during the entire 75 minutes. So cybersecurity has made a lot of news, and sometimes we don't hear this news in real time. There are a lot of reports out there. The intention of this chart is just to illustrate in the first 6 months of 2021, we hit a record pace for cyber breaches, cyber attacks on IoT devices affecting manufacturing and utilities, healthcare. The example of the Colonial Pipeline, which actually shut down fuel supply to the eastern part of the United States. And more recently in January, an example of Tesla electrical vehicles. A single security researcher had the ability to hack into 25 EVs in 19 countries, accessing keyless features, and even starting the engines. So the US and the EU and many countries are calling for IoT cybersecurity solutions. The industry needs to take action now. So without further ado, I'd like to introduce you very briefly to our two speakers. First up, we're going to have Sridhar Kali from the Department of Homeland Security. And second up, we will have Sharon Hagi, Chief Security Officer of Silicon Labs. And with that, I'd like to hand this off to you, Sridhar.
Appreciate it very much, Brett. Thank you very much to IEEE and all the folks here to make this happen. This has been a wonderful experience for us. I want to focus on the two aspects, cybersecurity and interoperability, specifically tailored to public safety use cases. So a little bit of background into DHS and why we are playing a role here is in terms of, who are we? DHS S&T was founded in 2003 with the establishment of the department. We're the research arm for DHS, and we're the science advisor to the Homeland Security Secretary. Primarily, we do research and development, testing, and evaluation for all of the DHS operational components, such as Secret Service, CBP, ICE, but we also support the first responder community in terms of the first responder and detection community, who is a major component of our stakeholder group. So in a summary, in a short word, we do science. So in terms of areas and disciplines that we actually look at, we manage programs across 6 major areas: border security, counterterrorism, first responder disaster resilience R&D, chemical bioexplosive and defense R&D, cyber information analysis R&D, and finally physical security and critical infrastructure resilience. And some of this will be evident in the next in the presentation. So what does S&T, specifically my office, the office I work for, our team is designated as the Office for Interoperability and Compatibility. Specifically, we look at communications networks as well as computing activities for the department. Specifically, we want to ensure first responder or operators can exchange information such as voice, video, data by addressing communications and networking challenges. Part of our focus area is also position, navigation, and timing, and ensuring that PNT is resilient and secure as it relates directly to critical infrastructure, such as the national grid, or used for providing services and timing. It's not just position, but it's also timing, such as, ATMs and the financial sectors use GPS for timing. So part of our office was actually a outshoot of the 9/11 Commission, specifically tying back to the fact that many firefighters and police department folks couldn't talk to each other during 9/11. There were huge compatibility and interoperability issues. And so we've been set up specifically to establish a comprehensive research and development, testing and evaluation program for improving interoperability, both in emergency response and day-to-day operations. We're also looking at new technologies and how do we integrate that new technologies into the fabric of first response communications and networking. And part of our efforts is to look at long-term technologies that could lead to advancements in emergency communications capabilities. And looking at the R&D, and we talk about RDT&E, which is research, development, test, and evaluation, specifically to address these issues. So that kind of leads right into IoT sensors. We talk about IoT sensors in a very ubiquitous fashion, without attaching a kind of a use case to it, and looking at what, how do they apply to first responders or, homeland security applications. What we know that IoT sensors present opportunities for public safety and homeland security. If you look across the federal enterprise, 56 of 90 agencies that were kind of surveyed had equities and stakes, and actually stated that they were looking at IoT sensors from everything from command and control, or to provide data for such as doing water quality management, border control, tracking ships in waterway. A great use case was internationally during the Fukushima nuclear incident. What we actually found is the Japanese government actually outfitted Arduino sensors for detection of nuclear radiation levels. And they put them everywhere. They put them on bicycles, they put them on UASs, and that was nothing but an IoT sensor. So if you were to kind of extrapolate, that's kind of another practical use case. What we want to use IoT is to provide enhanced resiliency, redundant communications. Specifically, wouldn't it be great for a firefighter to go into a building to know where the occupants, using Bluetooth connectivity information as well as Wi-Fi connections, we would be able to find out where the people are. We'd also know what are the conditions in the building. Are there any chemical sensors or any information that could then tell them how to dress appropriately? Do I need, breathing apparatus to get into the building? This is all information that you could glean from IoT sensors. Specifically, we are looking for efficient relay of mission required information, so to help either with automation, for example, dispatching resources and capabilities to a specific event. We're also looking at remote mobile diagnostics for patients and firefighters. A leading cause of deaths in the firefighter community is not only obviously from cancerous materials, but it's also, a lot of firefighters get heart attacks and other things because they're in situations where they're stressed, possibly dehydrated, and that could lead to other health issues. So we want to be able to track and check their performance. What is their heart rate? What is their temperature? We also are looking at video and data sources for public safety applications, everything from the body-worn cameras to information on where are the location of the fire hydrants for use during an emergency. The response team can use this IoT data collected through various information and including such as vehicle speed sensors, occupancy sensors, for everything from crashes to earthquakes. And I'll go into a technical demonstration that we did that actually stressed all of these things and capabilities to kind of evaluate, how do you integrate IoT devices into a emergency response situation. So the idea is that we really want public safety users to use this information to better prepare responders, save lives and property. So in terms of cybersecurity and key challenges for the deployment of IoT, there are a number of factors that we are looking at and we are concerned about. And by the way, this is all, some of this information can be gleaned. There's a link below that you guys can click to get information. Cybersecurity, I think that that Sharon is also going to talk about this later. With IoT devices that are kind of deployed everywhere, you're now increasing the attack vector. Specifically, if people can get to those IoT sensors, if they're not secured, it could cause problems. Specifically, we'll go through some of those issues, but you're now providing access to all of these IoT sensors in the field, and they are increasing the ability of malicious actors to mount larger scale attacks to these internet connected devices. A lot of the equipment that you're connecting to is not only just the IoT, but you're also connecting to a number of networks that these IoT devices are hanging on. That could then create issues relative to denial of service attacks, increasing and flooding the IoT information that's coming in to kind of overwhelm people on the other end or folks processing the IoT data. Things that such as, we are concerned about IoT devices being out in the field, and when they're deployed, there's an expected life shelf for these in terms of battery power and their ability to stay for sustained operations. Now, imagine, if you will, if a malicious actor can turn the IoT device to keep sending information to the point where it drains the battery and effectively makes it null and void, you have now increased costs that somebody's got to go out and, again, replenish these. These are all issues that are prevalent. The other issue is that a lot of cybersecurity devices for IoT just don't exist. It's sort of an open free-for-all at the moment. And being that the devices are cheap, I think people are starting to just deploy and put them out there without providing some basic guidance and information to ensure that they're protected. So what we're looking at is, how do we prevent malicious access to these devices? What can be done to prevent specifically impacting the public safety sector with regard to cybersecurity? The other issue is scale. How much information can be processed on the ground? Not all the information that is collected from IoT devices is useful for a public safety enterprise or activity. You could have information from parking meters all the way to smoke detectors, but what is useful to whom and when sort of gets into the whole challenge on the artificial intelligence machine learning component of it, in that we don't want to overwhelm the public safety users out there. If you deliver them the information that they need at the right time, with the right level of detail, and ensuring that that data is accurate, then I think you've really solved the problem here. But currently, this is a huge challenge. We are expecting public safety users to be doing their mission. They're not looking at their devices or looking at specific, trying to figure and make sense of all the sensors that they could potentially have access to. Congestion. We know that providing sufficient coverage and capacity for trillions of devices is going to be critical. In telecommunications networks, you always look for the perfect storm. You have a public safety event on Mother's Day. Essentially those are the busy hour traffic for telecommunications networks. When the network gets stressed, you want to make sure that mission critical data is always being able to be queued and offloaded appropriately, because that information is going to save lives at the end of the day. So competition for resources such as network access. We're doing a lot of work with folks at FirstNet, AT&T, to make sure that the mission critical data is always prioritized such that it gets through. And you have the worry of the front haul and the back haul in this type of environment. So looking at other challenges, there are three other challenges that I would like to sort of address. One is regulatory policy. Clearly, from a DHS standpoint and public safety standpoint, there is a lack of regulatory policy that says, how do we acquire these devices? What do the devices need to have in terms of security, in terms of to address vulnerabilities? How do we even use them and weave them into the actual mission space? Those are all critical things that have to be looked at. And finally, privacy with regard to policy. We are under very, very strict guidelines to make sure that the privacy of the public is protected. We want to safeguard all of that information. For example, if you are looking at an IoT device and it happens to be having a patient's vitals or information about a specific patient or a victim, you want to protect that at all costs. You don't want that information getting out. So that's kind of key. Interoperability is another huge challenge with regard to where we're at. There's a lack of comprehensive standards. Each vendor is building their own IoT device and expecting it to work in any kind of environment. That doesn't make sense for public safety. For example, I'll go through a couple of examples where that has become a real challenge. How do you take that data? Because the data has to be processed. There has to be an intake process for the data. It has to be processed and then delivered to either a common operating picture or a command software to allow you to address or direct resources to a specific response. And I'll go through an example. Finally, human impacts. I'm not going to go into a lot of it, but obviously we talked a little bit about the saturation and overstressing the public safety user at the edge by providing too much data that it's not actionable. So in terms of network-based threats, you have the IoT device in the center. It's obviously accessing a network where an attacker could masquerade as that IoT device and inject a whole lot of information that could be garbage. You could have malicious NFC tags. You could exploit the backhaul, exploiting a weakness within the 5G or the 4G infrastructure. You could intercept the data and eavesdrop on what public safety users are doing. Capturing and modifying sensitive data in transit. For example, if you are trying to trigger an alarm to go somewhere, imagine directing law enforcement or fire to the wrong address or to the wrong location. That could have significant issues. Again, having malicious Wi-Fi networks getting in there and either do hotspot hijacking or some other things. And obviously there are security issues with Bluetooth communications and using weak encryption algorithms. So to kind of demonstrate and kind of bring into perspective the interoperability piece and or use case for DHS, we actually did a technical demonstration in 2019. And this was based off of vignette that we created. It was based off of Shaken Fury, which was an exercise that was done nationwide, led by FEMA. And what we're looking at is a 7.7 magnitude earthquake in middle America that causes the Mississippi River to flow upstream. It actually changed the direction of the river in terms of how intense it was. And this was happened before. I think it happened in the 1800s sometime. So what we had is a football game at a stadium. You had, if you look at the top of the screen, you essentially had public safety users. You had a command bus set up, and you had police department, fire, ambulances on site. And then you had the emergency operations center, which was off site. And you had a building collapse of the stadium, and you essentially had to do search and rescue. If you look at the middle, there's a bunch of first responder, it should say active devices, but those are IoT devices. We have things like rad sensors, gas sensors, chemical sensors, UAS is flying and providing live video feeds. We had smartphones that were used to track location of people, body cameras, radios, and also health sensors that were put on patients. And that was to track all their vitals. So if you look at this construct, you have all this data that IoT devices are generating needs to go to the command bus. It has to go to the incident command that is in the middle of the, if you see the fire truck and the ambulances. It has to go to the incident command and then also has to be exfilled to offsite the emergency operations center. And this exercise, we prepared for it, and we essentially had a one-day exercise in Birmingham, Alabama. And so what was the architecture like? Well, this kind of defines the architecture. This slide, if you look, you have a personal area network, and if you look at all of these blue ovals, they are all the IoT sensors. The green ones can also be the IoT sensors, including heads-up displays and cameras, and incident localization module. That module is looking at where people are, both outside as well as inside buildings. And so if you look at it, you have a personal area network, an incident command, and a wide area network. And the communications from these sensors have to be processed, intaked, processed, and sent to the appropriate person. So if you look at the incident area architecture, the data that's generated has to go to the incident commander so he can direct resources to the people who are hurt, to the firefighters that need to be moved because they're in harm's way. So in this use case, look at the downstream effect. Again, you have the sensors all the way on the left. You have Wi-Fi, Bluetooth, or WAN type wireless connections. They go through various devices. they have to go to the internet, and then there's a STAPI server that has to be stood up to process all the data, to make sure it makes sense, and then go to the various, if you look at all the purple boxes, they are the command software that is being used by public safety. And none of them have a common architecture or a common software that they use. They all use different software. So it really becomes a challenge. And so if you were to take a look at it, we had to come up with a method of standardization of protocols and data and really create an environment where all the information, whether it's MQTT standard, MQTT or HTTP, depending on the format of the data and the protocols being used, to take the sensor data and drive it to the end. And by the way, I think you guys have access to the presentations and you can download them. But Audrey was a work that we had done with NASA Jet Propulsion Labs to leverage some of their artificial intelligence. And the idea here is the Audrey would essentially process the data and deliver the correct data to the public safety user. So for example, a firefighter would only get the alerts that he would be looking at for his geographical area, for his mission. So if there's any law enforcement or some other things, Audrey would filter that out so that you're not providing sensory overload. So what this kind of tells you is interoperability is going to be essential, and cybersecurity is going to be essential to driving IoT deployment in the environment. So what is the federal government doing? So DHS, specifically our team, along with CISA, and by the way, we also work with Canadians. I believe there might be some on the bridge today, on the webinar. But we work with the Canada's DRDC, Public Safety and Defense Organization, and we are working on doing joint demonstrations and sharing research and development to kind of optimize the adoption of R&D as it relates to public safety. So the Internet of Things, so there is a Cybersecurity Act that was initiated by Congress, and what it required is NIST to develop IoT guidelines and standards, and I believe I've referenced them. They've developed the NIST IR 8259, along with the SP 802-13. And the guidelines that they've provided is for manufacturers, federal agencies, as well as for consumer devices. But what the law requires is that OMB to oversee and review policies created based on that standard into the use cases for federal government. So we are working very closely with CISA and the partners and our DHS components to ensure that there is a policy in place. There are secure profiles, and I think Sharon's going to discuss this a little bit more. But these secure profiles are built into the IoT devices that DHS acquires to ensure that there's some baseline cybersecurity. And on the other hand, we're developing standards. I should say, let me walk it back. We don't develop standards, but we develop best practices and recommend standards be used. And DHS has put out something called the DHS Integration Handbook that is also downloadable and can be used by anyone. And by the way, if you want to contribute to the DHS Integration Handbook, feel free to reach out to one of us within DHS S&T. I think there is contact information available, and you guys can be cited and given acknowledgments for your contributions there. So resources, some of the diagrams and some of the things I've pulled, including the use case for the Birmingham exercise, is available on DHS's website. And feel free to engage with us with all of our social media platforms. And we look forward to hearing from you and working with IEEE and folks like Silicon Labs, as well as industry and academia. So thank you.
Thank you, Sridhar. Great presentation. Got a lot of Q&A coming in on your talk, so can't wait to get to that. Saron Hagee, I'd like to introduce you. If you could give a brief introduction to yourself.
All right. Thank you, Brent. It's a real pleasure to be with you all this afternoon. Before I get started, as Brent said, just a quick additional intro. So I'm the Chief Security Officer here at Silicon Labs. Silicon Labs is a fabless semiconductor manufacturer and recognized leader in providing secure, intelligent wireless technologies for IoT. And now increasingly also we're into edge application marketplace. So our products are basically SoCs that pack significant functionality that's integrated into wirelessly connected intelligent products, many of which contain sensors and drive sensor data acquisition and processing, involving basically a wide range of use cases and applications. And we work with tens of thousands of solution developers in most industry sectors, including industrial, commercial, home, and healthcare environments. So, this webinar is primarily centered on the efforts to secure intelligent sensors. Essentially, those are devices that measure some type of physical phenomena, convert analog domain signals to digital, and are responsible for processing that information, transmitting it, and ultimately perhaps reacting or taking some type of action based on feedbacks that are driven by this real-time telemetry. So to secure this process from an end-to-end perspective, it's really important to consider all the various solution elements that are integrated together to form the sensors-enabled application or solution. There's a need to analyze the end user needs and also consider the use cases from an abuse and misuse point of view, the device characterization and capabilities. This is actually often the main focus of what most are considering for IoT security. The connectivity models and paradigms. There's a plethora of different ways in which we can connect sensing devices and stream data through various interconnected networks to the internet and onto the various cloud and data processing centers. What happens to the data while it's being transported from the individual sensor all the way to the application and processing software that consumes it is of considerable concern. How do we know data is authentic? For example, how can we tell if it was perhaps manipulated or altered in some kind of an unauthorized fashion? How do we know the system can maintain confidentiality, integrity, and what happens when the sensor system gets disrupted or it fails? The effort to secure sensor systems has to start with the analysis and understanding of the threats and risk. In such an analysis, we consider how an adversary, be it a sophisticated, well-funded, or highly capable nation-state actor or a cyber criminal motivated by greed, all the way to the opportunistic amateur or hacktivist looking to maybe score a hit and cause some disruption in the name of notoriety. We consider those threats and their capabilities. We map those to systems and attack surfaces. Those are the, attack surfaces are the interfaces and the things that the attacker can act on using various mechanisms and techniques. Once we do that, we can understand better what mitigations or preventative controls we should be incorporating into the device, the network, or the software to reduce the risks inherent in such an interaction. Threat and risks analysis is nothing new. It's been in use and around in cybersecurity for decades. But what's important to recognize in IoT and intelligent sensor applications is that this analysis has both spatial and temporal aspects. And what I mean by that is that all solution elements that we talked about in the previous slide are exposed to different threat actors and threat factors for that matter, and have different attack surfaces exposed depending on time and location associated with their life cycle. from the early design and manufacturing stages all the way through to the deployment in the field, maintenance, and of course, decommissioning. So if you look at the hardware domain, for example, there's concern there that silicon-based parts and integrated devices and systems could be exposed during design stages. Things like sabotage or tampering and perhaps the introduction of critical vulnerabilities. These concerns, of course, shift during fabrication and other steps in the manufacturing and logistics pipelines. Things like interception of security keys and secrets, exposure to direct hacking are some more examples here. Physical tampering, by the way, is very much a real concern. The costs involved in sophisticated side channel attacks and electromagnetic glitching have come down dramatically in the last few years and are being aggressively commoditized. Similarly, if you look down here at the bottom in the software domain, code can be vulnerable during development. Similar concerns exist around introduction of vulnerabilities, tampering, sabotage, and direct attack can all impact the sensor or system hardware and software combination during various stages in the end-to-end solution lifecycle. These are all significant supply chain risks that the industry and consumers have come to recognize as needing real solutions as the increased reliance and dependence on sensor data and key confidentiality, integrity, and availability needs. So basically, to address the myriad of spatial and temporal threats and risks and deploy secure and highly resilient integrated sensor applications, it requires literally an industry-wide scale effort and collaboration. Security is everyone's responsibility, all stakeholders, and it's pervasive, both horizontal and vertical effort. And that requires extensive collaboration and partnerships, as we've heard earlier in Sridhar's presentation. That collaboration facilitates integration and interoperability of solution elements. You can see here there are many security requirements that need to be fulfilled, all based on sound principles, practices, and security mitigation objectives. We've developed what I consider as good characterization of what it takes to secure intelligent connected devices down to the silicon levels, where you can find foundations like robust cryptography, hardware-rooted identities, trusted processing environments that reduce the risk of tampering and data compromise. We've defined the foundations of trusted and secure communications and have been working with ecosystem partners to broaden adoption and secure protocols and APIs. There's considerable progress being made to secure cloud and software applications. Many companies like Silicon Labs are working hard to deploy support and infrastructure to help solution developers better manage risk and security throughout the product lifecycle, as you can see here at the bottom as well. Moving on. So historically, cybersecurity has been a lagging priority in technology industries, especially in electronics and in semiconductors. Over the last decade or so, the media has been reporting on many examples of cybersecurity breaches and attacks impacting IoT. We've heard about botnets like Mirai that commandeered home security cameras and baby monitoring devices in 2016. We've seen numerous examples of how critical infrastructure, hospitals, and even food supply chains can be impacted by debilitating ransomware attacks, even during a global pandemic. I think we all know that there's no Geneva Conventions when it comes to cyber warfare. Unfortunately, the industry as a whole hasn't been able to effectively coordinate well and rally around the problem. We haven't.
We need to make sure everybody's muted except the speaker.
Yeah, can you mute all of the speakers? I mean the attendees?
Everyone should be muted except the speaker, please.
All All right.
Okay,
Sorry
thank you, Sharon.
So anyway, going back to the point about the fact that the industry as a whole hasn't been able to effectively coordinate well and rally around the IoT security problem, we haven't seen sufficient scale and efforts to really step in and enforce some basic protection and address holistically fundamental security requirements to protect consumers and others. So it's no surprise that the lack of self-governance and self-regulation in cybersecurity is what compels governments to try to step in, and we're seeing it in these recent examples. Sridhar actually mentioned this in his presentation, the IoT Cybersecurity Act of 2020, designed to address government purchasing for IoT-based sensor solutions, and a lot of that stuff will likely bleed into consumer and industrial control systems. Also here, the Cyber Shield Act, stands up security labeling program, very similar in intent to something like Energy Star that we see on a lot of electronic devices, attesting to their energy efficiency labeling program, and that's something that we see a lot in the United States. And just recently, as May of this year, President Biden signed an executive order on improving the nation's cybersecurity that specifically calls for the Federal Trade Commission and NIST that we already mentioned, the National Institute of Standards and Technology, to stand up an IoT cybersecurity consumer testing, assessment, and labeling program. Again, both consumer software and consumer-based hardware. We're, of course, seeing the same efforts at the state level. For example, California was the first to introduce a law for all connected devices to have reasonable security. It was intended to protect information in the device from any access or modification. In other words, it surfaces the idea that devices should be able to resist hacking and tampering. All of this, of course, extends to intelligent and connected sensors. Governments tend to focus on what they define as reasonable security. But what exactly do they mean by reasonable security? I mean, it sounds a little vague. Well, in the United States, much of that determination is actually tasked to standards organizations like NIST. NIST, of course, is part of the U.S. Department of Commerce and has the mission to develop and design government technical standards. NIST actually was aware of laws like California SB 327, and so they've been collaborating internally for over a year on standards like NIST-IR. Again, Sridhar mentioned that as well, the Interagency Report 8259, which defines a bare minimum of security features for a connected, smart, secure IoT device. You can see many of the requirements listed here in the gray box. Some of them directly dictate security features that need to be present in an intelligent sensor integrated IoT device. Many of these will require a specific functionality at the MCU or MPU level of the device. For instance, there's a hard requirement for being able to securely update the firmware of the sensor product. This directly points to a root of trust enabled secure boot function, as well as secure over-the-air update feature integrated into the silicon. Another example, maybe just to mention here, is the basic requirement to control the logical access to the device's local and network interfaces for privileged elevated diagnostics needs. And this will require manufacturers to provide secure ways to lock and unlock the debugging ports of the silicon. So the U.S. basically is not alone in this swiftly moving effort to ramp up cybersecurity regulation for devices. The UK and other European countries are currently working within ETSI, which is the European Telecommunication Standards Institute, to enact similar prescriptive security features for consumer devices. You can probably tell by looking at the list of requirements here that there's a lot of commonality with the NIST-IR 8259. For example, here you can see again the updatability of software and firmware, ensuring the integrity of the software, which will require secure boot and secure update of firmware capability of an embedded device, tamper resistance, secure debugging, and other security mechanisms. All of these laws, standards, and certification present a significant challenging landscape for many of our customers to navigate. Laws define what's legally required, but they're not specific enough when they stipulate things like reasonable security. There's an implied expectation that organizations will perform the necessary threat and risk analysis that I mentioned at the start to really ascertain what is reasonable here. Standards will take those laws and try to define more detailed requirements. And jumping to the right here, you have certifications, basically ways to prove, demonstrate, and attest the achievement of compliance with the law, for example. But you really need a security profile or protection profile, as in the well-established common criteria terminology, to define the right level of security that the certification can be based on. A security profile, as we can see here, or we can start to consider, looks something like this. It will probably have to cover many different categories of security controls, like things like secure interfaces, contain robust crypto functionality. You might have various levels that can be tested, and some of these levels should be baseline requirements that are not optional, as represented here in the black arrow. For example, some of our secure integrated SoC products have been tested against PSA, CESIP, CAVP profiles, and with these certifications, we can attest compliance with the base security profile requirements of those standards. With additional controls and broader interoperability, we can cover, of course, additional requirements out of the box. So what's left at the end of the process is a delta that is very specific to the context of the sensor application and system in question. And it should be significantly easier for developers and product makers to address that delta certification than having to deal with all the requirements and complexity basically from the ground up. All right. So to summarize, we need more specific efforts to secure intelligent sensors, devices, and applications, and ground that process in comprehensive threat and risk modeling and analysis that has a spatial and temporal coordinate system. We need to create greater collaboration and interoperability to be able to deploy needed security controls. We need to be able to broadly leverage more secure, trusted controls rooted in silicon hardware and put emphasis on mature software security practices and build more secure infrastructure connectivity and cloud resources. All of these, of course, benefit from standardization and appropriate regulation. Reasonable security is basically all about effective risk management. And at the end of the day, this is what sensor integrated solutions really need most of the time. Thank you.
Thank you, Sarang. Excellent presentation. We've got a lot of questions coming in. So as we get to the Q&A, I just want to show one slide here. Let me advance this. Sorry about that. This one slide here is intended to just kind of talk about, oftentimes we think about the sensor is just a small component of it. Typically the sensor is not the attack point or attack surface, if you will. We've got to think about the entire ecosystem, as we've heard from our speakers today. And I also want to comment, although there have been a lot of cybersecurity attacks, they're not scaling as much as the IoT adoption is. So again, intelligent sensors are your MEMS and sensors combined with microcontrollers and an RF radio and a wireless gateway. We have rapid growth, but the adoption rate or the growth rate could be higher if we can address these standards. And these standards must address the entire ecosystem and the entire value chain, from the semiconductor manufacturer to packaging to integrators, gateways, and internet service providers. So cybersecurity professionals should be focused on the entire value chain to prevent exploitation of sensor data. So with that, I'd like to start some Q&A here. Got a long list of questions. I had a question about the Shake and Fury example, Sridhar.
Sure.
When a disaster like that takes place, how is communication managed when a wireless communication services are knocked out or inoperable? Immediately afterwards, or how do you deal with that?
So, great question. There are several ways that are done. For some of the larger events, it's kind of a mixed bag, right? You either operate with what you have, but if you have an event like Super Bowl or some of the other major events, wireless carriers actually provide service at the event. So you're sort of disconnected from the rest of it to provide the added capacity. For example, in Washington D.C. in the mall, you almost always have AT&T, Verizon, T-Mobile all bringing in trucks to provide deployable comms. The other answer is that we actually created our own hot zone. We brought in, like FirstNet, great example. They actually have a tethered drone that can provide 4G service. It's tethered and provides through an Ethernet cable down to the command truck, or the cow is what they call a cell on wheels. So that's one way they address it. In other ways, the bottom line operational mode for responders is their land mobile radio, and they go into walkie-talkie mode, which is no infrastructure. And their radios operate anywhere from 3 watts to 5 watts, and they communicate, but it's strictly voice at that point. It's sort of the way that it's managed. If all infrastructure is gone, that's how you operate. And I'll tell you, these guys are humbling. I mean, to work with a firefighter, work with a police, if you see what they do on a day-to-day basis, it's very humbling.
Yeah. So in an event like that, when you have a stadium, a football game or something like that, you're saying there are redundant communication pods brought in?
In some cases, in some cases you don't have them.
Okay.
Yeah, but you operate with what you have. Now, in a major disaster like Katrina or Sandy, FEMA actually rolls in trucks, and they set up and deploy communication systems for the first 48 hours while the carriers bring everything back up. So that's really the fallback position, but that's done at a national level. Over.
Okay. All right. I've got a question here from one of the attendees. What are the countermeasures that DHS has implemented against hardware Trojans that could be malicious, be inputted in IoT sensors?
So that is a great question. I don't think we have implemented anything to date. I think what we're doing is leveraging the work that NIST is doing and others are doing. It's always a catch-22. Sensors and IoT devices tend to be on the cheap. So they try to get these things developed and fielded at little or no cost. And so when you look at that, how much programming and other activities are actually put in them? Not much. So we are actually trying to create best practices working, and CISA's leading that effort. So some of this I'll have to defer to DHS, Cybersecurity and Infrastructure Agency, CISA, that is actually leading a lot of work in that area. And if you guys want to click, they have some great resources on 4G, 5G, as well as IoT.
Okay.
The best way, by the way, to prevent or to reduce the risk from Trojans. So obviously, for manufacturers and developers to really focus on, first of all, software security to make sure that the software that they make doesn't contain those vulnerabilities, but also secure the software supply chain, the components that they integrate. I mean, a lot of software today incorporates a lot of components from off the shelf and open source, etc. So the composition of that software has to be properly managed, and ultimately the way in which the sensor devices update their software, their firmware, those mechanisms have to be locked down and secured cryptographically. And I did mention the fact that secure boot and secure software updates using cryptographically rooted, hardware rooted root of trust is basically the way to prevent those issues.
But Sharon, if I can piggyback on what you just said, I think that's a great point. From our perspective, DHS can only drive industry to a certain point. The stuff that you mentioned, that is ideal. So from a perspective of where we are, we're trying to provide guidelines of what basic profiles like the NIST document lays out. Minimum profile settings that are going to be required, and we'll have to develop policy to make sure at least the equipment that we are buying has that rigor in supply chain, has that rigor in down to the silicon level, as well as the secure capability of doing, patches and software upgrades to ensure that cybersecurity is maintained and retained. Over.
Okay.
So great point.
I think we've heard a part of the answer to this question, but I want to go ahead and answer this question because it's being asked by an attendee. What is the most pressing cybersecurity issue that we're facing right now, and why? Is it us? Is it consumers? Updates? Sharon, can you take that one to begin with?
Yeah, I can try to take that one. So I think in my opinion, the most pressing issue is that too often we miss the opportunities to address even the most basic requirements to protect devices and data. We tend to think about sophisticated attacks and scenarios involving nation-state hackers in a movie-like setting where they're typing on keyboards and hacking their way into the most secure facility in the world. The reality is actually not like that at all. Hackers are actually lazy creatures. They don't like to work hard in something that may or may not be a good investment for their time and effort. So they tend to exploit the most basic and the easiest vulnerabilities first. And if they can find a free tool or an automated script, and if it doesn't involve a lot of effort on the part of the attacker, then you bet that they'll use that as a way before they'll ever think about something exotic or zero-day exploit that no one has heard about. So that's why I think as defenders and security professionals, we should focus on covering the basics first. Have risk analysis in place to guide priorities, have basic protection mechanisms in place, something as simple as locking debug ports and implementing trusted and secure ways to update and upgrade sensor software or firmware, making sure you don't have default passwords in a shipped product. Run your code through a static analyzer to see if there are any obvious buffer overflow vulnerabilities. These are all very basic steps and things that can go a long way in reducing risk and the impact of a potential cyber attack.
Okay. Okay, thank you. I'd kind of like to hear from both of you on this one. What role should the government play in ensuring sensors are secure? And again, this sounds like it's the sensor, the ecosystem is secure.
I think if from a government standpoint, I'll tell you what I think. I think that we have to ensure that industry, academia, they all follow certain guidelines, and what we can do at the base level is to do probably a couple of things. One is to ensure that we document our basic fundamental requirements and needs. So if we require certain things in supply chain, we need to put that out there, and we need to explain to industry what we need. We need financial incentives for industry to do and sort of follow through. And the third thing that we probably need to do is stay vigilant in terms of testing and evaluation to make sure that industry is doing what it's saying. Because, you know, we do have certain guidelines that we put out. For example, if DHS says tomorrow, you got to meet, you know, NIST guidelines for profile management for all IoT devices. If we put that out there, there's obviously a financial incentive for people to follow through. The bottom line is all of this traces to a large extent to dollars and cents. You know, you have to provide the guidance, and then you have to reinforce it with essentially the carrot and the stick.
Okay.
I'll turn it over to you, Sharon, to answer that question.
Yeah, no, 100%. I completely agree. I mean, the problem today is that there's no monetary incentive for companies to invest in cybersecurity measures to keep their products secure, and of course, that includes sensor-based products. So, as Sridhar said, you know, the government's role is to really create laws that put a monetary incentive on companies to think more about security and safety of consumers and the public at large. These laws, however, I mean, I don't think they're going to be the panacea, but it's definitely a good start. In absence of all other measures. You know, basically, if it's going to cost companies more to deliver insecure products than it will to deliver secure products, then I believe we'll start to see real change. Case in point, by the way, laws like GDPR in the EU, you know, GDPR being the General Data Protection Regulation, really made a huge difference in how data privacy is managed everywhere. And it created a lot of innovation in the information space along the way.
Okay, all right. Thank you. I have a question here about medical devices. One of the attendees is asking about medical devices. Something about 70% of IoT medical device ransomware infections are caused by the user. If either one of you, Sharon, you might can speak to that. I'm not sure. What would the user do that would create a vulnerability like this, if you know?
It could be a lot of different things. You know, oftentimes attacks propagate through the use of phishing and social engineering. A user might be connecting a medical device to a PC in order to update or to upload their medical data to the physician, and they might connect it through a USB or a Bluetooth connection as an example. And at the same time, they might have clicked, like 5 minutes before that action, they might have clicked a phishing email that caused some malware to be installed on their PC, for example. And that malware that now has a vector into the connected device through that device to PC connection, for example. So it could be that, it could be a lot of other things. You know, the things around the device and the actions of the user could definitely cause something like that to occur.
Okay, all right.
Yeah, I would echo that, specifically phishing. I think, if I'm not mistaken, I think they did trace one of the major hacks for ransomware down to a whole bunch of them, actually, to phishing attacks and the fact that they weren't using very disciplined admin passwords and things like that allow you to get into the systems. You know, I think we could probably shut down 70 to 80% if we maintain the rigor of making sure and follow through with discipline to make sure you don't click on links that you don't, you know, that you shouldn't.
Yeah, okay. Got another question here from an attendee. Who is responsible when an IoT device or network is hacked or infiltrated, government or OEM? So who's responsible? I'm not sure that's.
Well, I mean, it's a question of, you know, I think it's government's responsibility to make sure people are well informed when they do things. But at the end of the day, if a hack occurs, you know, who's really responsible? It doesn't matter. What matters is the hack occurred. You know, and each of us are responsible for our own. I mean, if you have a baby monitor, it's your responsibility to make sure you buy a baby monitor that is UL listed. I'll give you a great example. That we know people who are using baby monitors from overseas, and it winds up impacting communications because it happens to be in the wrong frequency. Simple things, but those people who are buying and requiring, these things, they need to have some sort of education to say, when you buy things, look for this, look for that. And on the government side, we need to protect our critical infrastructure, our basic, requirements and infrastructure should be locked down to the maximum extent possible.
Okay.
I agree, and I think and I kind of alluded that in my talk when I said security is everyone's responsibility. It's even the consumer's responsibility, right? Like there's nobody who's going to prevent a consumer from clicking on a phishing email but the consumer, right? So that's basically what we have here is a situation where we can either spend a lot of time kind of dividing up the liabilities when something happens, or we can focus on collaboration, interoperability, making sure that everybody understands their role, and together as an industry and as an ecosystem and as an industry sector, for example, talking about medical, together, all of those things will help protect consumers and devices. No individual element within the solution is going to be able to do. There's no silver bullet here. So that's basically my opinion here.
Okay. And when a person goes into an electronic store, buys an IoT device, is it obvious when I'm standing there at the store shelf or e-commerce, whatever? Is there a marking like a UL mark? Is there a certification marking on these safe products?
So there are some initiatives that are happening across various alliances and various ecosystems. It depends on what product we're talking about. Today, the answer is complicated. In some cases, yes, there is something like that, like a food label that basically tells you that these devices were certified to some definition of a device profile, as I've mentioned in my presentation. In other cases, it's not the device, but actually the components in the device that have been certified. And then, it depends on whether the manufacturer took that and certified the device in its composition. So today, that's actually one of the issues that requires better regulation and better coordination. And that's really what the cybersecurity acts that we're seeing coming from U.S. government are about. Is about creating that attestation, that labeling system like Energy Star, that when you go and you buy a computer monitor or a TV and it has that label on it, that implies certain degrees of energy efficiency standards have been applied to that product. And so that's what we're looking for from a security perspective, is the concept very similar to Energy Star or food label that would give the consumer a sense of what certifications, what standards this particular device has complied with.
Okay. So we've got time for maybe one or two more questions, and then we'll finish up with a few concluding slides here. I've got a question here. What role does the FDA currently have in existing regulatory authority to establish cybersecurity standards for medical IoT devices? I think you had a slide that described one agency, but there may be a different answer than that.
So for medical devices, there's and it's complicated because there's different categories of medical devices. There's, I know we're dealing with a lot of, for example, devices in the artificial pancreas and insulin, automated insulin dispensing fields, and that there's specific requirements there, security requirements that are being developed by DTSEC and the IEEE, and those are subject to FDA approval and oversight. So that's what's happening in that area. But again, it goes down to the type of application. There's certain baseline requirements that electronic components that go into medical devices have to fulfill. right? Basic criteria for security and cybersecurity. And then there is the additional qualifications that are required for a particular device using specific use cases. And that's the Delta certification that's left in order to comply with, let's say, an insulin pump versus a heart rate monitor, as another example.
Okay. All right. We're just about out of time here. I want to thank you both for a very enlightening presentation and webinar. I feel like this webinar really got to the crux of the matter, better so than numerous cybersecurity webinars that I've watched over the past 2 years. It sounds like we're making progress, but this really seems like the right opportunity to advance standards, and IEEE Sensors Council is in a good position to do that. So I want to thank you both again, and there's a few more slides I'd like to go through here as we conclude the webinar. I want to mention the IEEE Sensors Registry. So this is something that is being, I'm going to say, popularized. We're trying to advertise this. It's a data reviewed for accuracy and authenticity. There's no fee for early access. And signing up for access, you can do it now through this sensorsregistry.ieee.org. And so I'm not going to read through that entire thing there, but this is IEEE Standards Association registry, where you can list your products. And I think this would be advantageous to many of the OEMs and suppliers and people in this whole ecosystem. I want to announce here this webinar series. There may be additional webinars, but what we're doing is this thing is going to culminate in an industry roundtable meeting to discuss the industry needs for IoT-enabled sensor devices with specific focus on interoperability and cybersecurity. This meeting is going to be held in late March. It's going to be March 30th and 31st in Austin, Texas. And so who should participate in this? We're looking for senior industry executives and leadership, anywhere from C-level to CTOs, CISOs, and CIOs, product architect and managers. So, you know, what we're looking for is we're looking for a good mix of semiconductor suppliers, sensor manufacturers, systems integrators, end users, OEMs, test laboratories, and test solution providers. This is a great opportunity to come together and collaborate with both your partners and your competition, if you will. We've got to address this as a group, as an industry, and that's the intention here of this industry roundtable, is to launch this program that hopefully turns into an initiative with an IEEE. So you've got there a date and an email for contact if you have interest in participating in this roundtable. This is a really, really important and good opportunity to come together. This is going to be a face-to-face meeting at this point in time. So please, we'd like to see your interest in this. And I also want to take note here that there is going to be a survey at the conclusion of this webinar. And so please finish that survey and submit it to us, and stay tuned. There will be additional IEEE webinar series on the outcome of the roundtable. So if you don't attend the roundtable for whatever reason, expect another IEEE webinar series that that discusses and announces the outcome of this industry roundtable. So with that, I would like to conclude today's webinar. I want to say thank you again to Sridhar and to Sharon from Silicon Labs and the Department of Homeland Security. This again has been one of the most enlightening cybersecurity webinars that I've attended. So thank you all, and thank to all of you attendees for sticking with us for 75 minutes. And we'll see you soon. Thank you.